Action potentials occur when a positive feedback cycle proceeds explosively. They are pulse-like waves of voltage that travel along several types of cell membranes. At stage 0, or resting potential, both of our sodium and potassium voltage-gated ion channels are closed. Our sodium and potassium ions are positively charged and our membrane is negatively charged. In stage 1, a graded depolarization brings a portion of the excitable membrane to its threshold, beginning to open the voltage-gated sodium ion channel. In stage 2, the sodium channels are fully activated and the plasma membrane becomes more permeable to sodium, causing it to rush into the cell's cytoplasm. At stage 3 of the drawing, the inactivation gates of the sodium channels close as the voltage-gated potassium channels open. The positive charged potassium move out of the cytosol, shifting the potential back towards resting potential. Lastly, repolarization begins. From stage 3 to 4, the potential drops and overshoots to negative 90 megavolts. At stage 4, the sodium channels remain inactivated until repolarized to threshold levels. They are back at normal status of being closed, but can open if need be. Then the potassium channels begin to close as it reaches resting potential again. While potassium channels closes, potassium ions continue to leave the cell, causing brief hyperpolarization. In action potential, there are two important periods that occur. On the graph shown, the red part is known as the absolute refractory period, in which the membrane cannot respond to further stimulation. The green part is known as the relative refractory period, in which the membrane can respond only to a larger than normal stimulus. To sum action potentials up, the influx of sodium ions from the extracellular matrix during depolarization will cause the efflux of potassium ions from the intracellular matrix during repolarization, and then during hyperpolarization, too much potassium leaves. And the few ions that do cross the membrane are pumped out again by the continuous action of the sodium-potassium pump with a ratio of 3 sodium ions for every 2 potassium ions. This is action potential.